Ever wondered how to build an AI agent that can see? In this tutorial, you will learn how to create an autonomous agent that can surf the web and assist you in performing complex tasks solely using vision.
Hi all, it's Will from LangChain. Today I'm going to be teaching you how to build a vision-enabled web browsing agent using LangGraph. LangGraph is an open source framework from the LangChain team that makes it easy to balance expressivity and control when building cyclic type LLM workflows such as those commonly used for AI agents. If you're not familiar with LangGraph, we've got a nice introductory series of videos on YouTube that you can check out, as well as a number of examples in this repository here that you can see to see more basic examples of how to build with it. Hopefully through the course of building this vision-enabled agent, you'll see a little bit more and understand a little bit more about the types of workflows that it really empowers you to build. For our example, we'll be building this based on the WebVoyager paper by He et al. Of Zhejiang University. They haven't released the code yet, so this is my best impression or understanding of how the agent operates based on the description in the paper. The agent itself is a basic reasoning and action loop type of agent. If you're familiar with React-style agents, what it does is it generates a chain of thought saying why it's going to make the next action to improve its accuracy there, and then it'll give the action for the tool, and then the arguments is going to be passing that, and then that will then call an API, and then we return and decide to continue to loop until the LLM decides it has the answer or has accomplished the goal that it was set out to accomplish. Once that state is reflected, then it returns that output or response to the user there. When building a web browser agent, there's a number of considerations that you're going to have. For one, if you're just feeding it raw text, it's going to have a lot of useless information that is all going into this machine code that actually isn't helpful in getting it to the end state. In general, when building agents, you want to reduce the complexity as much as possible, reduce distractions as much as possible, so that you can make it as resilient as possible and give it a better likelihood of actually accomplishing its end goal. Um, so the web was designed for human eyes. But even then, if you pass in a big screenshot like this, it's kind of hard for it to get that level of precision just from generating text. So they have a nice approach that uses this set of mark style bounding box annotation that will generate these bounding boxes around the different things, and then it can then select these elements by number, and then use the browser or the mouse in order to make these clicks and other types of actions. This is a nice way of creating affordances for the or UI affordances for the agent so that it can actually interact in a more successful way. If we look at this diagram I made, the basic structure is as follows. You have the state of the graph, which is basically the web browser that we annotate with these bounding boxes. You have the question, the trajectory, which is just the past series of actions that it's taken so that it knows not to repeat itself or it knows what it's tried before. You have the LLM and prompt here encoded by the brain. And then you have the tools. Tools in general are just the API between the LLM and the outside world. In our case, the outside world is the web browser. So we have things like scrolling, typing, clicking, waiting, going back, and going to a search engine. Um, I put this together pretty quickly. I haven't optimized it at all, so a lot of these examples could probably be made more resilient by either giving it more tools, increasing the parameter size, or improving the prompts, etc. And so a lot of this type of building, you can probably optimize more for your use case. One thing that makes it really easy to do that is LangSmith. So you can click here and you can sign up for an account. I already do. And this gives us a nice set of traces that you can look through and help debug and develop your application regularly. We'll get back to this a little bit later once we actually start running code. So once you sign up for that, again, it's optional, but highly recommended. And if you need to get an account or get off the wait list, you can feel free to follow up with us offline. You can email us at support@langchain.dev. So we'll set up the API key here, and then we're going to be sending all of these to this little project here to WebVoyager later. And then installing the requirements, we require LangGraph, this package, and then LangSmith for tracing, and the LangChain OpenAI wrapper, which is it gives a runnable API to the OpenAI SDK. And then if you haven't already, you can install Playwright. Playwright is the browser technology that allows the LLM to be giving a control to that. You could also use Selenium or other things like that. It's not super important for this case. And then this is just a step that allows the async browser to be operating in a Jupyter notebook. So wouldn't need that in production, but for the sake of the notebook, could do that. All right, onto the agent. Basically, when you're creating a graph, it is a stateful graph, and you can think of it as a state machine. So then what dictates the next step is both the state and the series of connections within the graph to determine like what you're going to be doing next. In our case, we've got a number of elements here. You've got the web page itself, so this is a page within Playwright. You've got the user input, and then you've got some things like the image and the bounding boxes, as well as its prediction, and then you have some of this other things, so like the observation of the tool once it actually does and clicks or types on things. It's just a simple string. And then the list of messages, so if it's going to be saving additional information in the messages, we can keep track of it there. You can try tweaking this to see if you can get better performance than what I have already configured here. Once you define that state, we'll start creating the tools, which again are the API between the LLM and the browser. You see in LangGraph and in the stateful graph, we accept this state into each of these tools, into each of these functions, which are nodes in the graph. So in this case, for the click operation, where you get the page and then the arguments that are passed by the LLM, which in this case are the bounding box that we have, as well as the, that's actually it. The bounding box, then we can look up in this list of B boxes up above, and we can get the XY coordinates, which are the pixel level information about where we're going to click. The other functions are defined similarly. So for typing text, again, you have the bounding box, and then you also have the text content that you're going to be typing into it. So if it needs to search, if it needs to be filling out forms, it can use this. We've got some information to overwrite here and all that other stuff. We've got this scroll operation. Right now I'm keeping it simple and not even letting it tell the tool how far to scroll. This could definitely be improved, but it lets it go and navigate about whenever you can't see all of it in a single browser view. You can wait for things to load. You can go back a page as it traverses, and it can jump back to Google, which is kind of like a get out of jail free card here in this case. I'll run this cell, and I forgot to run the previous cell. So here we go. Now that we have the tools, we can actually define the agent, and this is kind of the fun part. The agent, as we mentioned before, is really composed of a couple things. There's the annotation part, so the thing that actually goes and takes the screenshots and generates the bounding boxes, and then that image will be passed to the LLM. And then there is the prompt and the LLM. Here I have a JavaScript file that's also in this repository. It just generates bounding boxes so that we can screenshot it, and we'll just unmark the page afterwards so that we don't have those bounding boxes follow us along as we go and navigate the web. This will be the annotate function, and then we have this parsing function here. So when the LLM generates raw text, we take that and then we look for this action prefix, and then whatever arguments are semicolon separated and return it there. Again, you can try playing around with different formats and other types of things to make this more robust if you need to. We are storing the prompt on the LangSmith hub. So you can see what it looks like here. I'll go and have this prompt ready. Then you can compose it with the LLM and the agent. This pipe syntax, if you're not familiar with it, is basically a part of LangChain expression language. All it does is it creates a new object by composing these together. So the output of prompt goes into LLM, which then goes into this output parser thing that takes the text from the overall output message, and then this function that we just defined above, which is parse. This is a single unit, and we're assigning it to this variable prediction in the output, and then composing that with annotate here. So this annotate function again here is what takes the browser and generates the bounding boxes. Once you define this, if you want to see in a more visual format, oops, I scrolled up. You can even get graphed, ASCII. Now I need to print that, and you can see basically what I was saying. So again, it's all piping, similar to bash piping. The data will flow through these different pipes, and then the output of this will be assigned to the prediction value here, and then the output of this, whatever keys are going into here, will then be joined in the output. My Jupyter was messing up there for a second. If you want a quick view of what the bounding boxes look like, I pulled up this the screenshot here. So you can see we just go and look for things with hrefs basically, and then we'll draw these things around it. The LLM thing is to say, I'm going to click on number 18 here, and so then we can resolve those using the bounding boxes to these things here. It makes it easy again to help the agent interact with this world. Once we go here, we are time to start creating the actual graph. We've got one more function that we need to define in order to finish our workflow here, which is the update scratch pad. Basically, anytime this agent will loop, we want to be able to format the observations, the tools, into a structure that we can then put back into the prompt eventually. So what this does is it looks at the string output of those functions that we defined above as tools, and we then will be parsing it a little bit and then just putting it into this list of previous actions, and we'll just number as steps and putting that in the scratchpad variable. When we investigate the traces in LangSmith, you can get a better sense of how this is working. Now it's time to actually compose the graph. So if you're not as familiar with LangGraph, I'll take a little bit longer to describe these operations for you. If you are very familiar with it, then you can probably skip forward a few seconds. The basic steps here are going to create this graph builder object from the state graph, which then takes in that agent state above this type that we defined above, and that is basically the state that is a part of the state machine. So anytime a node returns, it updates the state. We then start adding nodes and defining edges. Nodes again do the work. Edge define how the work is then routed between each of the different units. So we add the agent that we did above, and we set it as the entry point. So when the user calls it, it first goes to the agent. Next, we're going to add this update scratchpad function because we just created it. And we're going to say every time the update scratchpad function returns, next pass that state over to the agent. Again, this is because we're completing the loop there from any time the tool is called, and it goes back to the agent to make the decision of what to do next. After that, we've got this list of tools here that we're going to give each a name, and we're going to add them to the graph. And then we're going to add an edge that says anytime this tool completes, go back to that update scratchpad node that we define here. And then finally, before I get too far, you'll see this is again that piping expression language syntax. All this does is it says the tool function that we defined above, first do that, and then wrap that in a key called observation. So it takes the string, puts that in, and then says this is the observation key that you turn from it. And again, this is because we defined the observation in the LangGraph state. It'll then update that after this node is called. We finally will create this single conditional edge that will determine the whole structure of how logic is routed. Basically, after the agent runs, this function will be called, and then it will take the output of the agent and then decide which of the other nodes to go to. So if the action is answer, then we'll end, and so the user can see the final result that the agent returned. If the action is retry, which if you look back above, is just output if you have a parsing error or something like that. This lets the agent handle issues if it outputs in the wrong structure. Otherwise, we return the actual action itself. Since we named the action the same value that we put in the prompt for the LLM, we can just directly have it output and it'll route it right back to that node. So we'll do this. The compile step just takes this builder and creates the graph itself. And then it's time to play around with it. Let's see how we did. First, we're going to create the actual browser object, and then there's a helper function which will just print all the things out to the notebook so we can watch it running in real time. So you'll notice it opened the browser and navigated to Google. I'll go back here, and I'll first, all right, for our first question, we're going to ask, can you explain the WebVoyager paper on archive? So we'll give it a little guidance here. As you remember, LLMs as today, they haven't been trained on data that's very recent, so it certainly doesn't have baked in knowledge within its parameters of this paper. So it needs to use the web browser to see. So you can see first it sees, it says, I'm going to type in WebVoyager paper archive. It knows how to Google, good. And then it clicks number 27, so this little paper here. And then once it actually decides to move on from there, you can see it opens it up. And you can see, follow along also in the browser here. You can see it's opening there. And then it responds to the answer. So it presents a study on building end-to-end web agent with large multimodal models. It's an advancement and web GPT models, detailed architecture training, and okay, so it doesn't, it's a little bit lazy. It just likely details this. It doesn't actually go and scroll through, but you know, it got the gist. It was able to get there. So let's give it another question. Maybe explain today's XKCD comic for me. Why is it funny? So I'm not sure how much of a sense of humor these models have, but we'll see if it can explain. It's starting from the same point that we left off before because, as we mentioned, the browser is just, it's there. So it knows to go back to the start, and then it searches today's XKCD comic, and it goes to the search bar there, finds it. Oh, you see it has these things here, and then gets all these nice pop-ups, but it's able to stay true and ignore them for now. And we'll see if it can click. Number 24, which one is that? It actually takes me a while. Oh yeah, it just clicks the link there. This is on a slight delay, so you can see it actually did open it up. And what I like about this little display is it shows what it looks like to the agent as you go through. So it gets the final response and says, shows an image, seems to be curious observation about the greenhouse effect. It shows a timeline with two significant historical events. And it talks about James Watt, who kicked off the Industrial Revolution, and then some of it. So the humor is a juxtaposition of the early recognition of the seriousness, but it's been a while. So we haven't made that much progress. A little bit of a depressing comic, but a classic for XKCD. We can see if it knows how to find what the latest blog posts are from LangChain. Again, it may or may not know what LangChain is, but it knows how to use these tools because we've given it instructions. So it starts at XKCD, looks up Google, and then we'll see what it does after that. These first couple of questions follow a similar pattern where it goes to Google, it does a search, does a couple of clicks. Relatively straightforward. So maybe we can see if it can do a more complicated task next. It's going through, opens this up, and then it's able to read that it has OpenGPTs and multi-agent workflows and LangGraph. So look at that. It seems like we're actually getting the right stuff. Again, this model is only taking in the image and then some of the instructions that we're having. So it's kind of impressive it's able to read all of this from the browser. Let's give it a more challenging one. Let's tell it to search a one-way flight from New York to Reykjavik for one adult and analyze the price graph for the next 2 months. So lots of steps. We implicitly, if you remember above, give it only 150 steps to complete, so we can see if it can complete on time. So it's starting from the LangChain blog, and we'll see it goes back to Google there to start out. Agent, we'll see if it can use Google Maps. This is a little bit more challenging since it's less of a strict old-fashioned web page. You actually have to navigate different things within it. We'll see what time it needs, or I should leave to get to SFO by 7 o'clock, starting from SF downtown. And then let's see what it does. It'll take a little bit of time. So again, it goes to Google, looks at Google Maps. We can even follow it in real time on the browser. Looks like it's opened it up. What is it going to do next? All right, for our last one, we'll ask it something a little bit different. We'll see if it can navigate Google Maps. So what time should I leave to get to SFO by 7 o'clock, starting from SF downtown? And this one will probably take a little bit of time, and we'll see how it does. So starts by searching for Google, SF downtown. So it doesn't even start by going to Google Maps. 10. Not sure where it's going actually. Oh, there it goes. Google Maps. It's got there. Looks like it is thinking it's 7 a.m. because I haven't passed it the current time, so that's another thing that I can probably improve. X0. It's X out of there. A little interesting. Looks like this is what it's seeing here. So it's going through and clicking a few things. Looks like the driver had an error here, but it's going to try to get through some things. and it's starting a little bit. One thing that we can do now is as good at a time as any to check out is you can look at all these operations within LangSmith. And then you have this whole record that you can share with your team to go and debug exactly the steps and inputs that you had that led to each situation. Um, so you can look at all these LLM calls, which again corresponds to those agent calls, to see the series of steps it had. So again, we asked it, so can you check here, and then this is what it was fed in. And then you can say it thinks, so fine, I need to search for this information on Google Maps. First, it's going to type and say SF downtown. It goes through and makes some decisions. You can check SF here. You can look at click 10, these things. You notice that we're only passing the most recent screenshot. We're not passing previous ones to show these different observations or anything like that. Maybe it's something you could try out later on to see if it improves. You can go to some of these decisions, and it looks like it's fed here, and it says, so you ask for this, I should initiate a search for directions on the map, and this is click 0. And so that's a little bit interesting. One of the things that I like to do with here is you can open up in the playground and then say, maybe if I updated the instructions here, I can actually test it out. So it's not actually trying to click 0, maybe it's trying to type 0. Um, so maybe I can go in and change some of these instructions here, or say web browsing, and say remember to type when needed, as this will also select and submit the request for you, or something. Again, I am not an expert prompt engineer, so we'll see how that goes. And then once you have that, I've already added my API key, and you can hit start. And it's GPT-4v, so it takes a little bit of time, but then you can start seeing what it'll take. So yes, oh, it says the search query here is already entered, and so it says so you can make some updates. You can keep on changing around things. Maybe you'll say it's clicked here, etc. I think one other issue with this is it seems like the bounding boxes aren't correct, so you could improve that actual affordance layer. But again, all of this lets you go and see the exact steps that you need to be taking, and then go and play around with it to improve in the UI without having to change any of your code initially. You can go and step through each of these steps and then see exactly what has been done. We'll go back here. It seems like it's getting a little bit closer, but it ran out of steps. So this is a little bit too challenging for this agent using the existing setup. And so we will have to go in and make some improvements if we wanted it to be able to do something like this. Anyways, I think that's enough for today. Hopefully I've shown you a couple of things. You've learned how to build something that looks like this WebVoyager paper, which I think is a pretty cool set of ideas. I've taught you, and you've been able to build something with LangGraph, which lets you go and write regular Python code, or you can try the JavaScript code as well, and just compose everything together in a nice little graph that you can then build and improve to balance some of this control with some of that more magical AI type of experience. And you've also gotten something that can go and browse the web for you. So I guess, again, if you want to get access to LangSmith or you want to try building this out, you can check out the LangGraph repo to see these examples that we've shared, or you can sign up for LangSmith at smith.langchain.com. And finally, don't forget to subscribe to the LangChain channel. This will help you stay on top of all the most recent AI advancements and give you nice tutorials such as this on how to build different types of agents, RAG, evaluations, and all those types of things. We'll make sure that we keep the content fresh and that you stay up to date. So thanks again, and until next time.